Students, good morning. Today I am going to discuss about the entropy change for an ideal gas. Entropy change for an ideal gas. Let us consider a piston cylinder arrangement. It contains 1 mole of an ideal gas. 1 mole of an ideal gas. N is equal to 1, hence PV is equal to nRT, hereafter PV is equal to R into T. Clear? Now the gas is allowed to expand. The gas is allowed to expand. Okay, for this expansion process, the internal energy of the gas gives the force. That means certain amount of force exerted by the gas to lift the piston in the upward direction. Certain amount of force exerted by the gas to lift the piston in the upward direction. Clear? Right. At the same time, the same amount of force from the surrounding is exerted on the piston in the downward direction. Gas gives certain amount of force to lift the piston in the upward direction. At the same time, certain amount of force from surrounding acts on the piston to push the piston in the downward direction. What I am trying to say is, pressure is almost equal, approximately constant. The pressure is approximately constant. Approximately constant. Hence, the work done by the gas for expansion is dW is equal to P into dV. Clear? P into dV. Now the first law of thermodynamics. Is dU is equal to dQ minus dW. I am going to rewrite this equation. dQ is equal to dU plus dW. So dQ is equal to, instead of dV, CV into dt plus P into dV plus P into dV. Divide by temperature on both sides. That is, dQ by T is equal to CV 1 by T into dt plus P by T into dV. Since it is an ideal gas, I am going to replace pressure in terms of R T by V. Again, dQ by T is equal to CV into 1 by T into dt plus R T by T into 1 by T into dV. Right? Okay. The final form is dQ by T is equal to CV 1 by T into dt plus R into 1 by P into dV. dQ by T, this is second law of thermodynamics. Already we discussed it. This is del S. dQ by T is nothing but del S is equal to CV 1 by T into dt plus R into 1 by P into dV. This is a differential form. Now I am going to differentiate between the limits, initial to final. So S2 minus S1 is equal to CV into ln T2 divided by T1 plus R into ln V2 by V1. This is the entropy change for an ideal gas. This is the entropy change for an ideal gas. Instead of CV, Cp minus Cv is equal to R. Hence, I can write like this: Cv is equal to Cp minus R. So this equation becomes changes in entropy is equal to Cp minus R into ln T2 by T1 plus R ln V2 by V1. Clear? So next step, Cp into ln T2 by T1 minus R into ln T2 by T1 plus R into ln V2 by V1. Clear? Next step, Cp ln T2 by T1, this minus change gets changed positive plus R into ln T1 by T2 plus R ln V2 by V1. Right? Next. Next. Changes in entropy. Ts is equal to Cp ln T2 by T1 plus R into ln T1 by T2 into V2 by V1. Ln T1 by T2 into V2 by V1. Clear? Okay? For an ideal gas, P1 V1 by T1 is equal to P2 V2 by T2. Okay? Now I am in need of T1 by T2 into V2 by V1. Okay? So P1 by P2 is equal to this term there, T1 by T2, this term here, V2 by V1. Substitute this here. So the final form Ts is equal to Cp ln T2 by T1 plus R ln, what is this, V1 by V2. Changes in entropy of an ideal gas in terms of Cp. This is changes in entropy of an ideal gas in terms of Cv. Next, we have three processes: constant temperature pressure process, constant volume process, constant pressure process. Now I am going to rewrite this equation. Okay. When pressure is constant, P is constant, changes in pressure is equal to 0. Hence, this equation becomes Ts is equal to Cp ln T2 by T1. The another form is P1 V1 by T1 is equal to P2 V2 by T2. In this equation relationship, P1 is equal to P2. Pressure is constant. Hence, V1 by T1 is equal to V2 by T2. Okay. So T2 by T1. T2 by T1 is equal to T2 by T1 is equal to V2 by V1. V2 by V1. So the another form is Cp into ln V2 by V1. Both are same. This is constant pressure process. Next one is constant temperature process. When temperature is constant, changes in temperature dt is equal to 0. Again, P1 V1 by T1 is equal to P2 V2 by T2. T1 is equal to T2, hence P1 V1 is equal to P2 V2. Okay, now in this equation, Ts is equal to, when temperature is constant, this will be eliminated. The remaining thing is R ln P1 by P2. This P1 by P2 is equal to V2 by V1, because P1 V1 is equal to V2 V2. P1 by P2 is equal to V2 by V1. So the another form of this equation, changes in entropy are into ln V2 by V1. Both are same. Next, this is constant pressure process, isobaric. Constant temperature process, isothermal. Next one is constant volume process. V is constant. V is constant. Hence, dV is equal to 0. Use this equation. Volume, when volume is constant, this equation becomes ds is equal to Cv ln T2 by T1. In this equation, put V1 and V2 same. V1 is equal to V2, hence P1 by T1 is equal to P2 by T2. I am in need of T2 by T1. So T2 by T1 is nothing but T2 by T1 is equal to P2 by P1. So another form is changes in entropy is equal to Cv into ln P2 by P1. Both are same. So this is the information regarding changes in entropy of an ideal gas. Thank you.